commit this stuff. I wonder what change I made to OpenGL render. Just remove that line. Let's say OrbitControls. Working. And now I'm going to try getting a projection, using a camera projection that uses 3D. I think that should help. That should make the zoom look more normal. And how do I do that? Well, somewhere, this is not it. Somewhere I'm passing in the camera's projection matrix here. I'm no longer passing in the view matrix because I'm doing that from the render, I think. Nope, where is it? Where is the view matrix getting set? It has to be somewhere around here. Does it happen in this? Shader wrapper uniforms? Model projection. Where is it? It gets set in the OpenGL renderer. Isn't that where I was looking? 346? Okay, don't know why I didn't see that before. But it's passing in the view matrix. This is basically, this encodes the camera's position and orientation, things like that. It's from scene camera get view matrix. So if I overwrite get view matrix, matrix to shader, this is just inverting the model matrix. Oh, I'm looking for the projection matrix. Let's go here, and this is just using a standard orthographic projection matrix. Okay, and that's, I want to update that. Okay, so this is the orthographic projection matrix. The formula for this is fairly cookie cutter. I didn't do anything crazy. Wait. None. Okay, so it's defaulting to using the frame width and the frame height. And the far and the near, it's using 1 and depth plus 1, which I guess I'm using 20 for the depth. But I'm just going to bring over the formula for a perspective projection. I'll look in Wikipedia, actually. I think that's what it's called. I'm looking for the matrix. So there's the formula, but I think there's a near, a far, near. What is R? Oh, I think I remember this. One of them is going to be the field of view in like degrees. Near, far, left, right, top, bottom. And these parameters are going to trace out a pyramid. Near and far, that makes sense. Left, right, top, bottom. Those will be sort of annoying. I think there's a way to do this just with the angle of, for the field of view. So I'm going to look for that. Can I get a... perspective projection matrix? One of these should have it. Come on, give me the matrix. Looks like it's building up to it. S. Okay. So you need the far and the near to trace out the limits, the beginning and the end of the frustum. S. Okay. So you need the far and the near to trace out the limits, the beginning and the end of the frustum. Then this S value only depends on the field of view, and it's this vertical field of view. I don't know if it's vertical or... Oh, it looks like it's horizontal field of view. I don't think it should matter, though. I think it's a square. I'm going to try copying this basically verbatim. And see if I can be able to zoom with perspective. So I'll need a field of view. It's multiplying by pi over 180. I guess this is converting to radians. Which I think makes sense. I think radians would be kind of hard to measure and for a field of view. Height, won't have a height. I will need a near and far. Okay. Although maybe... No, yeah, I think this makes sense. Let me calculate this S thing, this scale. 1 divided by the tangent of the product this and the field of view divided by 2. I'll just add parentheses there. Those aren't parentheses. And here. So divided by tangent. I think I don't need the parentheses here. Okay, and then the array that I'm going to want. I already have the far and near by default. I say if FOV is none. I think 65 or so makes sense. I don't have a ton of experience with this, but I think 65 is a decent one. And now I'm just going to copy this in. Scale 0, 0, 0. Scale negative f far divided by far minus near. And here we just have -1. Okay. And then here we have negative far times near divided by far minus near. The fact that this isn't auto-formatting makes me nervous. Expected right bracket. I don't get it. Oh. I have a -1. This should just be negative far. Alright, so did I copy this right? Scale 0 and 0 scale. That looks right. Negative far divided by far minus near. Then we get -1. Okay, so I'm going to try now. I'm going to pass this projection matrix instead of the orthographic one. Wish me luck. Okay, so now I can zoom with perspective. It is distorted though. And so now you can see more what's happening. If I get too close to an object, it starts disappearing, of course. And then if I get too far away from it, it's like a rendering thing, it'll also disappear. I guess my far plane is super far. Well, eventually it'll start disappearing. But now this has perspective. One reason a lot of people don't... Eventually it'll start disappearing. But now this has perspective. One reason a lot of people don't like this type of projection... there was a different core dev who was telling me about this. Parallel lines are no longer parallel. If I like zoom in a lot and then like look at a weird angle, the lines that are supposed to be parallel, like the sides of these planes, maybe it's kind of hard to see from this, but they're not parallel. Because in real life, parallel lines that are extending away from you won't be parallel. But anyway, I wonder if I can prevent it from looking so triangular. Like, why does it look like a triangle like that? Oh, you know what it might be? It might be because the screen is a rectangle. Would that do it? This does look like it fits nicely onto the screen. Yeah, that's definitely it. It's like the size of the screen is affecting the way it's projected. I think that actually makes sense. Since the field of view, this will be creating a square. This will be projecting onto a square. Can I get more information on this? Yeah, it's projecting onto a square. But the screen isn't a square. So when it fits that projection onto the screen, it makes a rectangle. So the question is, how can I make this not be a rectangle? Because no one would probably use it like this. I think I'll need a more complicated formula for the projection matrix. Like, I don't know if only the field of view is enough parameters. And I think the more complicated... So this has a perspective projection formula with 6 values. Maybe I need this one. Is this even the same formula? It looks different. So I have scale, scale. Yeah, this does have more entries. Though I guess in the formula that I'm using, right and left must be the same thing. Right? I guess that still doesn't make... This would be like 2 times right divided by... This would be divided by 0. Top and bottom would also be the same thing. So this would be divided by 0. Maybe that's why these are zeros in this. No, I don't know. I'm just going to try using this formula. And this one's gonna not take a field of view. It's gonna take a near, far, left equals none, I guess. How did this do it? This had a width and a height, which I think makes more sense. I don't think it makes sense for the left and the right to be different. So I just do width equals none, height equals none. Near equals 1, and the far can be depth plus 1. Then I can take the defaults from the dimensions on the screen. So that'll give me the width and the height. And then I'll basically just copy this verbatim. Where left and right. Well, this will actually have a problem. Right minus left. This will just be 0. Left and right. Well, this will actually have a problem. Right minus left. This will just be 0. Right? Though this obviously doesn't just crash if the right and the left are the same. Oh, here it is, a symmetric version. A simplified form of the perspective projection image can be used for symmetric projections, where r equals negative. Oh, it's a negative. And top is the negative at the bottom. So I'm going to do this. Near divided by right, width over 2. Near divided by width over 2 should be like this. This is near divided by the height over 2. Then I have far plus near divided by near minus far. This 2 times far times near divided by near minus far. 0, 0, negative 1, then a 0. Don't know what those numbers mean, but hope it works. Okay, I'm just going to double check this. This is near divided by right. That's width over 2, so I just bring the 2 up. Then I have near divided by top. It's height over 2, so I bring that up. I have far plus near divided by near minus far. They have 2 times far times near divided by near minus far. Negative 1 and 0. Okay. Wish me luck. Well, it is a square. It's just super far away and distorted. That's interesting. Why would that happen? Maybe I could just tweak these. Because it is doing what it's supposed to do. The square appears as a square now. Is 11 too far away? Also, I think the angles are off. Like I can go further than the limits of what I specified. Config at frame width. This is like... this is 8, this is 14. The depth is 20. I don't think that's that weird. I wonder if either the near or the far needs to be different. I guess that's the only thing I really have control over. I'm gonna put this at like 5. It actually looks a lot closer to normal. I don't know why these angles are different. Like I thought this was bounded at pi over 2 for how far down I could go. So I look at the example. The maximum polar angle I had at pi over 2. Why is it? The projection shouldn't do anything with allowing the camera to go, oh. This was going further than pi over 2, wasn't it? Well, it stopped now. Oh, it's only when I zoom in a lot? Does that make sense? I don't think it does. There might be a bug in that. But it did look a little bit better when the near plane was 5 instead. But it did look a little bit better when the near plane was 5 instead. I guess if it's 11 away, let me try making this 7 or something. Maybe it'll look more normal. Yeah, this isn't quite working. I think it made more sense. Whoa, hold on. I think it made more sense when I was doing it this way, although it was... Wait, wasn't this projected super weirdly before? Hmm. I don't know if I'm going crazy. This projection looks a lot nicer now. Oh, but it doesn't have zooming. Why did that stop working? This one had zooming. Things are like randomly working and not working now. Oh, this one was orthographic. That makes perfect sense. Oh, and that's why the zooming doesn't appear, because it's an orthographic projection, so it doesn't have perspective. That makes perfect sense. What I wanted to... The way I should have tested is by taking the 2 off of this. And this is how it was originally projected. And this also has this thing where I'm going beneath the floor, which is weird. And that might indicate a bug in the OrbitControls logic. Unfortunately. What I'm going to do right now is just stick to the orthographic projection. If/when I want to go into the perspective, I'll know what to do. Or where to start looking to debug, at least. But for now, I'm going to use this. That was a fun aside. Although, why would that happen with the angle? That was really strange. I'm gonna have to actually... I should go to the regular... or the symmetric perspective projection. The symmetric perspective projection. And just print out the polar angle on each frame. And I think I calculate it as part of this. Did I get like camera polar angle somewhere? I get a potential polar angle. Oh, then I get a current polar angle. Yeah, I'm just gonna print this. So this should be the angle off the z-axis. And here it's maxing out at pi over 2, which is correct. If I pan this somewhere... Oh, what happened? Oh, it needs a sign? That's true. I'll compute this sign. wonder why that didn't crash before. I guess it's only computed in one of the if blocks. Anyway, if I pan this, nope, still doing something. Need the camera y-axis. Where's the actual camera y-axis? Here. Okay, so get the camera y-axis. Okay, this. Okay, so get the camera y-axis. Okay, this should. Nope, same thing. What do we got? No camera position. Where is it looking at the camera position? Okay. Self.camera.get position. Position. And I need it again over here. So you go here, here. Okay. This time for sure. Okay, now I can pan. And now, if I pan, it's not doing it now. Is it only if I zoom that I can? Yeah, it's if I zoom, then I can start going above this maximum angle. So some conflict between zooming and the angle calculation. Why would that happen? On mouse scroll. Oh, I think I know what it could be. Maybe? Maybe what's happening is that I always want to compute, I always want to compute the polar angle off the z-axis. But currently I'm translating to the, what is this doing? I translate to the origin each time I do a computation. So maybe it's possible that this is the origin, this is the z-axis, and the target is like here. And this is the camera. The target is always restricted to the XY plane. So this will be the XY plane. I'm computing that angle off the z-axis. No, even if I compute the polar angle off the z-axis instead of the target, I don't see how I could end up under the ground, basically with a higher polar angle than I'm allowed. If I zoom, then do this. It happens every time. Okay, I'm gonna not print. Well, I will still print this. Well, I'll comment this. The polar angle it's computing when it checks the boundaries has to be wrong. So what it's doing is it's multiplying the camera's model matrix by this rotation matrix, but it's not writing that to the camera's model matrix. Instead, it's just using it to check whether or not that angle will end up being too much. So I guess I'll print this one. Okay, zoom in, do this. So now it thinks the offset from the z-axis is here. Well, it thinks this is pi over 2. Why is that? Rotation matrix. Get the camera's position. Axis rotation, blah, 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 blah. Could translating it? Oh, that makes it's axis rotation, blah, 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 blah. Could translating it? Oh, that makes it's obvious. Maybe it's not obvious. The polar angle off the z-axis here, this angle off the z-axis, this theta, of course that's different from the angle off of this axis here or whatever. These angles have very little to do with each other. And since I translate the camera to the origin when I do this computation. Wait, I'm translating the camera to the origin, computing, well, it's the other way around. I translate this to the origin, so it's looking at the origin. I compute this angle. I check that this is within the bounds, then I move it back, and then there's a totally different angle. So, how should I do this instead? Everything works except for that one check. That's the one thing that doesn't work. Although I sort of deserved for that not to work. Because this felt like a super janky thing to do even when I did it. So I move it here. Maybe what I have to do is... yeah, this part wasn't right. This angle isn't computed. It's always computing the angle off the z-axis. But it's computing this angle off the z-axis, then I'm translating it away. And that's going to have a totally different angle off the z-axis. So maybe I can compute the angle off the z-axis before I translate. Will that help? Rotation off the z-axis. I get the position in the y-axis. I do a cross product to find the axis of rotation. And then use that axis of rotation to get a rotation matrix. I use this rotation matrix to check the bounds after it's already been translated. Maybe what I need to do is, for this part, I can translate to the origin, rotate, and then translate back. For this part, the potential polar angle. How will I compute this? This is the polar angle that it will have if I multiply by that rotation matrix. I guess the potential polar angle is what you would get if you were to translate it, apply the rotation, and then translate it back. Okay, so I'm gonna have to complicate this some more. Unfortunately. Alright, so this is rotation around the z-axis. Translate, rotate, translate again. Here's rotation off the z-axis. At this point, the camera is still over here. Now I can get its position, its y-axis, the axis of rotation. This isn't right anymore, I think. The camera's y-axis with the camera's position. That might be correct. I wonder if this is all I need to do. Let's look at the axis of rotation. I think that's fine. I wonder if this is all I need to do. Let's look at the axis of rotation. I think that's fine. Oh, well, no, it's not. Camera position will change. It will change after I translate it. So this will give me the rotation matrix. Then I just convert that to homogeneous coordinates and then check the polar angle that way. Camera position, camera y-axis. I think what I need to do is I have to simulate the entire operation. So simulate the rotation. So I would say potential. Time to go. All right, see ya, Nunu. Have a good one, man. Potential camera model matrix. This is going to be the self-dot camera, dot model matrix, left multiplied by the translation this is translating it, then rotating it. Translating it, then rotating it, then translating it again. This is the potential camera matrix. New line, new line. Right? So these are going to happen right to left. Translate to the camera, rotate, translate back. Okay. Camera target, so this will work. Then... will I have to convert anything to homogeneous coordinates? I don't think so. Why did I do this? Get the axis rotation and rotate around that. Oh, this is for rotating around. Yeah, I will have to get a rotation matrix. So I think all I can do is do the first of the translations. So this, comment that. Here I'll have to find that axis of rotation. So here would be the position, axis, axis of rotation, this. So this would be the potential. I'll just call it camera position. But I can't use the camera to get the position. I'll have to get the position from the potential matrix. This will be potential camera model matrix at all of the first 3 rows and column 2. Nope, column 3. Since homogeneous coordinates will store the location in the last column. So look at the potential model matrix after translating. Let's call this potential translated model matrix. Get the position from that. Get the y-axis. And that's going to be this, the potential translated model matrix. Then I'll take the second column of that. Get this axis of rotation. Cross the camera's y-axis with a position. That's an interesting way to do it. I guess the camera's y-axis will be like this. And I'm crossing that with the position vector, which is like this. Y-axis. And I'm crossing that with the position vector, which is like this. Y-axis cross position. And so that gets a vector pointing in the plane, in the XY plane. What does this code do? Can you show me? In fact, I can show you. Give me 1 second, one more second with this. Yeah, it's going to get a vector pointing like into the XY plane, which is fine. Let me see if this isn't crashed. It probably is. Let me just run this, see if it doesn't crash. Oh my gosh, nothing's crashed. Anyway, I'm writing these controls, these orbit controls, for this OpenGL engine that we're writing as part of this open source thing. And the OpenGL infrastructure is really new, so that's why it needs to be done. Are you dealing with quaternions? Luckily, I didn't have to deal with them directly. There's some utility code within the library that does use quaternions, but I didn't have to use any knowledge of quaternions to use them. I thought I was going to, which would have been pretty fun actually, but I ended up not having to. Okay. How do you get rotations done? Complex numbers. So it is using quaternions. What I usually do, well, in the simplest case, I just wrote out these rotation matrices, these. And so sometimes you just multiply by one of these. If it's around an axis. If it's not around an axis, then there's some library code already written. Specifically this one is what I usually end up doing. That'll do that for me. I wouldn't actually need to use this. I don't think. Z to axis without Z axis. Yeah, I wouldn't actually need to use this, but it's just convenient. But this actually doesn't use quaternions either.